All right, good morning. This is weird standing here talking to an empty classroom. So every now and then I'm gonna have to look up and tell somebody to be quiet even though there's no noise. If you listen though, you might be able, if you're in art, you can probably hear yourself downstairs at times. Anyhow, we're gonna talk about pressure. This is the handout. If you're a face-to-face student most of the time, I gave you the handout yesterday so you would have a hard copy, just in case you don't have a printer to print it off at home. It's also under classwork, the classwork page that says PDF, and it will have pressure. And then you're going to have another assignment, remember, that will have pressure dash homework questions, okay? So it's two different assignments there. One is just a reading in this video, the other one is your homework questions, okay? All right, so what we're going to talk about is pressure. We've been talking about this for a couple days now. In physics, pressure is defined as a force over a given area. Okay, given the same force, the smaller area of contact, the more pressure is applied. So basically, remember we talked about if you're walking in the snow with just your shoes and then snowshoes, the less area is going to apply more force or more pressure to the area. As you spread it out, it's a little bit easier to maneuver there, okay? And that, as you can see on the reading, it's pressure equals force divided by area, okay? So how is it measured? And we've talked about this. The standard unit of measure for pressure is the Pascal, okay? Which is abbreviated as a PA. It's also the Newton per square meter, as shown by the formula above, okay? Other units that are used for pressure includes pounds per square inch. That's when you put air in, like your tires of the car. That is, you do the pounds per square inch. They use the bar, and they use the standard atmosphere, the ATM, okay? Example problems here. If a block weighs 60 newtons and is lying on its side with an area of 2 meters by 3 meters, what is the pressure exerted on that surface, okay? This is very basic math. It can get somewhat confusing if you're not careful, okay? But again, you're looking for the pressure, okay? And that equals force divided by area, okay? So if the pressure is 60 newtons, okay, it gives you all this. So you got 60 newtons, okay? And you're divided by 2 meters by 3 meters. I'm hoping that you can see that. I tried to set this thing up so you can see it. I know it's not going to come through real clear. I will move it closer so you can get a look at it. Anyhow, so what the first thing you got to do, if you think about it, if it's in parentheses, that's the first thing you do, okay? So you got to go 2 times 3. 2 times 3 is 6, okay? So it's 6 meters squared, okay? And then you're dividing that into 60. So 6 to go into 60, 10. And since it's measured in pascals, it would be 10 pascals. Okay? I'm going to bring you over and let you get a little bit better look at that, hopefully. Okay? Again, as you can see, you got 60. It's right off your paper. But all you do is you just multiply 2 times 3, and that gives you the 6 meters. Okay? And then you divide the 6 into 60, and that gives you the 10 pascals. Okay, so it's really not, it's not hard at all. It's really not. We're going to work one more. Let me be right back. Okay, let me erase this one, and we will do one more. We'll just work the other one there also. Okay, because it is a little bit different, but not by much. Okay. You got 60 newtons, okay? And it's divided by 2 times 2 meters times 0.5 meters, okay? And again, you just multiply this. So the 5 times 2, 0.5 times 2, if you remember how to do math, okay? You got that, and 0.5, and that would be 10, and then you have to move the decimal in 1. So that gives it 1. That's where the 1 comes from, okay? And then, of course, 60 divided by 1 is 60. So obviously that one gives off a little bit more force, okay? And that's what we were talking about up top, okay? Air or atmospheric pressure. One important type of pressure is the pressure that exerts on objects from the air on the Earth's atmosphere, okay? Or the Earth's atmosphere. This is actually the measurement of the weight of the gases above an object on a given surface area. Okay, we've talked about that for a couple of days now. The higher the elevation, the lower the atmosphere. Okay, think about it. If you got a lot of air pushing down, okay, and it's got a lot of weight coming down, the higher you go, you climb a mountain or something like that, the air starts to get thinner because you're moving up towards the top. Okay, so doesn't have quite as much pressure pushing down on you. Okay, and that's what this is. The higher the elevation, the lower the atmospheric pressure exerted because there is less air pushing down on that object. Okay, liquid pressure, of course, that's air also, water, anything liquid, but air is considered a liquid. Okay, it's also important to figure out the pressure underwater or in a liquid. The pressure underwater increases with how deep you are. Because again, think about it. At sea level, you've got a certain pressure. Up in the mountains, you've got less. But as you go down into the water, deeper into the water, you've got all of that pressure pushing down, including the water. Okay, so that's going to be under more pressure. Okay, the pressure underwater increases how deep you are. With how deep you are. The equation for calculating and pressure under liquid is pressure equals D times G times H. Now the D is the fluid's density. G is a standard gravity, which is 9.8 millimeter square. We know that because we studied that in gravity. I'm sure you all remember that. And H is the depth of the object in the liquid, okay? We're not going to work one of those. That's a little bit more complicated, probably more so than what we need to worry about in 6th grade, okay? Pressure in the state of matter. Pressure is also an impact on the state of matter phase of the matter. We often think of states of matter from changing from solid to liquid or liquid to a gas based on the temperature, but the pressure also has an impact on the state. In most cases, the higher the pressure, the higher the temperature needed to change the state, okay? Remember, put a little drawing on the board the other day about, I showed you how the solids the molecules in a solid is very close together. Even though they're vibrating, they can't pass each other. Liquid they're moved apart, so when they hit, they will actually pass each other. That's what makes it a liquid, okay? The gases are spread out really far. It's very hot, very warm, so it's going to spread out even further, okay? Heat makes things move away. The cold makes them come together, okay? One example of that is boiling water, boiling point of water. At a higher elevation where the air pressure is lower, the water will actually boil at a lower temperature, okay? Around here it's like 212 degrees Fahrenheit. You get up in the Rocky Mountains, it's going to be a little bit lower because the atmosphere is so much lower up there, okay? Think about if you're a football fan and you watch the Denver Broncos, a Mile High Stadium. Somebody makes a really long run, what is the first thing they do? They go to the sideline and they get oxygen on because the air up there is thinner than what a lot of these athletes are used to, okay? Interesting facts about pressure. The Pascal was named after the French physicist and mathematician Pascal. 1 Pascal is a fairly small amount of pressure. It takes about 101,325 pascals to equal 1 atmosphere. Some items, such as a tip of the nail or the edge of a knife, are designed with a very small surface area in order to maximize the pressure exerted by that force. That's why it's really, really sharp. You don't have to put a whole lot of pressure on that to drive it through a 2x4, okay? Submarines have to be specifically designed to withstand high pressures when they are deep underwater. Air pressure is often measured with a device called a barometer. You're going to see that again, by the way. Most barometers today measures air pressures in millibars. Hurricanes, if you watch them, sometimes when they're talking about hurricanes, they're talking about the different bars. How many bars is it? That's what they're talking about, the millibars. Changes in air pressure are important for weather forecasters because they can indicate changes in the weather. Again, you can actually feel the pressure, outside pressure drop sometimes, and especially in the springtime. If pressure might be up, and when it drops, you're probably going to get a rainstorm coming through. Okay. One of the things that we couldn't do for an experiment, the guys, you ever seen these guys that lays down on the bed of nail, and you're like, wow, why didn't that hurt? Well, it's because, again, it's kind of like the ship in the water. He has spread out across all that, so he's not applying a whole lot of pressure to any particular point. That's why. Okay? Well, I told you it would not take forever. This is about a 11-minute, a little bit better 11-minute video. You have plenty of time. Do the reading. Go back in and do the reading. Don't just watch the video. Actually look at the reading that we just went over, okay? And then answer your questions, okay? Do well on the questions, okay? You want to do well on homework. That way, if you do stump your toe on a test, you got something to fall back on, okay? Believe it or not, I actually miss you guys when you're not around here. This is weird. I don't like this. I'll talk to you later. Bye.